And we're back. So here is the 5-1 and 5-3 quiz review. Please stop me and ask questions if you need to. I find this stuff relatively simple, but I know some of you guys might not. So please, if you're like, whoa, where'd you get that number? Please stop me and say, like, whoa, explain that. All right. Find the indicated, come on, get up there. Find the indicated area for each under the standard normal curve. That's kind of worded really weirdly. To the left of z is equal to negative 1.26. Z is equal to negative 1.26. So to the left of. Now, do I have to do anything funky with the number that I get in the table? No, because I say to the left of. And those are the values that I have in the table. So I'm just going to look here. What was it? Negative 1.26. So I'm just going to go to my first page. Negative 1.26. Here's my sixth column. Negative 1.2. 0.1038. 0.1038. 0.1038. Is that what you guys got? Yeah. Bingo. Between negative 1.32 and 1.71. So negative 1.32. Okay, here's negative 1.32 is all the way over here. So negative 1.3, 0.0934. Oh, that's, oops, nope. 0.1112. Whoops. Oh, I was right the first time. 1.32. 0.0934. 0.0934. And then the z-score of 1.71. 1.71, one column right here, 0.9564. 0.9564. 0.9564. Now remember, area can never be negative. So I'm always going to take bigger minus smaller. You can think of it as like the bigger z-score minus the smaller z-score as well. So I've got 0.9564, take away 0.0934, and that'll leave me with 0.863. Okay. To the right of 0.68. Now the z-score, the area at 0.68 to the left, 0.68 all the way over here, 0.7517. 0.7517. 0.7517. Remember, that is the area to the left, correct? That is the area to the left. So how do I find the area to the right? 1 minus 0.7517 is 0.2483. Between 1.03 and 2.25. Same thing there, right? 2.2, oops, let me get to this. 1.03. Let's do 1.03 first. 1.03. Yeah. 0.8485. 0.8485. And then 2.25. 2.25. Big number. 2.25. Here's my 0.05. 2.2 is in the white. 9878. 9878. And we subtract those two. 0.9878 minus 0.8485. And that gives me 0.1393. Questions on number 1? Feel good about that, right? Pretty simple there. No context to it. Just given the z-score, find the areas. Remember, z-score table is always going to be to the left. All right, let's take a look at number 2 then. During a recent test, Mr. Laverick's students scored an average of 78 points with a standard deviation of 8.4 points. Assume that the scores approximate a normal distribution. I can't even do this problem unless I say this. Right? We don't know how to do this right now if I don't give you that statement. Assume that the scores approximate a normal distribution. Calculate the z-scores for games where they scored for games. For points. For tests. Where they scored 92 points and then 72 points. 92 points and then 72 points. So 92, right? 92. Let's calculate the z-score there. Remember, z-score is on your table, or on your formula sheet. You know, if I just flip over to chapter 5, z-score is x minus mu divided by sigma, right? X minus mu divided by sigma. So z is equal to x, which is 92, minus mu, which is 78, divided by the sigma of 8.4. Okay, so z-score is going to give me 92 minus 78 divided by 8.4, which gives me z-score of 1.67. You can always round z-score to nearest hundredth because that's what you have in your tables. So 1.67. Is that highly unusual? I mean, it's on the far end, but
Not highly.
right.
Isn't it too early?
Anything 2 or higher would be pretty unusual. And then we have the z-score for 72, which is 72 minus 78 divided by 8.4. Remember, it's always x minus mu. It's always x minus mu because if it's lower than the mean, then the z-score is going to come out negative. So 72 minus 78, which is, in other words, for 6, negative 6 divided by 8.4, going to give me a z-score of negative 0.71. Z is negative 0.71. Good there? Pretty simple. And again, remember what z-score is. Z-score is just like the standardized version of that value. You know, it's just kind of like putting it in perspective for us. You know, just telling me that I've got 92 and 72 and the mean is 78 doesn't really tell me, you know, are those values unusual? Well, knowing the z-score kind of interprets that for us. Assume the continuous random variable x is normally distributed with a mean equal to 42 and a standard deviation of 9. Find the indicated probabilities. Now, again, what is this asking you to do here? It's asking you to say, now give me the area under the curve with the knowledge, with the the frame around it that I'm using for probability, right? I know that the mean is equal to 42, so mu is 42. And I know standard deviation, sigma is 9. Mu is 42, sigma is 9. Find the probability that the x value is greater than 55. All right, now, greater than 55. Isn't that to the right of 55? So what I'm going to do is I'm going to say, well, that's really equivalent 1 minus the probability of x less than 55. Because the less than is always going to be calculated by the area in the table. That's the value that you're going to get in the table, the less than, to the left of. Okay. Let's calculate that z-score. The z-score of 55 is 55 minus 42 over 9. Okay, 55 minus 42 divided by 9, that gives me 1.44. So I go to my table now, and I'm going to say the probability for the left of 55 is it has a z-score of 1.44. Here's my 4 column. 1.44 right there, 0.9251. 1.44. 9251. So I have 1 minus 0.92. What did I say it was? 45? 9251. Whoa. 1 minus 0.9251 is 0.0749. So out of context, I know that the mean is 42, the sigma is 9. Mean is 42, standard deviation is 9. If I want to know the probability of getting a number bigger than 55, knowing that the mean is 42, knowing that the standard deviation is 9, that's a really low probability, right? A 7% probability. 7.5% rounded probability. All right, let's find the probability of getting a number between 36 and 68. All right, so the first thing I need to do is figure out those z-scores. Z-score of 36 would be, again, 36 minus 42 over 9. 36 minus 42, negative 6, over 9, negative 2/3, so negative 0.6, negative 0.67 rounded to the nearest hundred. If I want to do 68, that is 68 minus 42 over 9. Okay, 68 minus 42 divided by 9, which gives me positive 2.89. So now I'm going to find the probabilities for each one of those. Got to go to my table. Negative 0.67. Negative 0.67. Here's my 7 column. Negative 0.6. 0.2514. 2514. 2514. 2514. 2514. So 0.2514. And then we do 2.89. 0.9981. Thanks. Appreciate it. And again, if I want the numbers in between there, the probability in between there, I just take 0.9981 and subtract away 0.2514, and that gives me 0.7467. So now I can say picking a number between 36 and 68 is just about a 75% chance happening. Knowing that the mean is 42 and the standard deviation is 49. Questions about that? So let's put some context to it now. Put some context to it. The average weights of newborns are normally distributed with a mean of 10.2 and a standard deviation of 1.7. So mean is 10.2 and sigma is 1.7. One newborn from the sample is randomly selected. Find the probability that the newborn weighs less than 11.6 pounds. Okay, so I'm really calculating probability of X less than 11.6, right? To put it back out of context. That's what I'm trying to find. Probability of X is less than 11.6. So I need to find the z-score at 11.6. So 11.6 minus 10.2 divided by 1.7. So 11.6 minus 10.2 divided by 1.7. And I get 0.82. 0.82. 0.82. Now, I'm saying less than this, so I don't need to do anything weird with the number in the table. Now, you know what I had a lot of people do? I remember this from last semester. This is like making an alarm go off in my head. You know what a lot of people said right here? Oh, it's 82% chance. Don't confuse z-score with probability, right? Z-score you use to get the probability. Always get the probability off of the table. 0.82. Positive number. 0.82. Here's my 2 column. 7939. 7939. So probability of X less than 11.6. 0.7939. Think about, it's interesting that it actually comes out pretty similar. But that's just coincidental. Right? Find the probability that the newborn weighs between 12.3 pounds and 13.7 pounds. Now, based off of what we see here, what should, 12.3 pounds. It's pretty high above the mean, right? More than one standard deviation away from the mean, at least, right? And 13.7, ooh, yikes, right? That's a big baby. So that means that the probability should be a little low, right? Just have that in your brains. So again, I want to know, putting it out of context now, 12.3 less than X less than 13.7. That's really what we're finding here. So let's find 12.3. 12.3 minus 10.2 divided by 1.7. That's the z-score of 1.24. And then the other z-score of 13.7 minus 10.2 divided by 1.7 is going to give me 2.06. 2.06. Okay, so the z-score of 1.24. 1.24. Here's my 4 column. 0.8925. 8925. Come on. 8925. 0.8925. We'll put it right underneath that so we have it right there. 2.06. Shoot, I keep doing my calculator. 2.06. 9803. 9803. 0.9803. Bigger minus smaller. 0.9803. Oh, we'll get back there. 0.9803 minus 0.8925. 0.0878. So about a 9% chance of that happening. Still not crazy out of the norm, but less than 10% chance of that happening. Last one for this one. Find the probability that the newborn weighs more than 14.2 pounds. Ooh, big baby. X is greater than 14.2. So let's, now remember the write up, right? Greater than, newborn, weighing more than 14.2 pounds. That's 1 minus the probability of X is less than 14.2. And that's on the table. So I go 14.2, forget the z-score, minus 10.2 divided by 1.7. And that's a z-score of 2.35. So 2.35, right here's the column, 2.3. 0.9906. 0.9906. 1 minus 0.9906. 1 minus 0.9906 gives me 0094. So a less than 1% chance of that thing happening. Less than 1% chance that the baby's going to come out more than 14.2 pounds, which is good. So we're going to do. That's why. All right. Questions on 4. All right. And the last one here, number 5. In a survey of men in the United States, the average male sleeps 7.3 hours with a standard deviation of 1.4 hours. Assume the sleep times are normally distributed. How long should 95% of men randomly selected? How long should be sleeping? That's worded really weird. How long should 95% of men randomly selected be sleeping? That should be. Yeah. So 95% of men. Well, 95% of men, that's 0.9500, right? Let's find that z-score that matches 0.9500. 0.9500. Oh, gotta go to the table again. 0.9500. Did we just do this? 950. Wasn't that 1.645? Yeah. 1.645. Yeah, because it's right in the middle there, right? 1.645. So Z is 1.645. I'm gonna put the work down here because now, and again, and this is your table. This is in your table. Sorry, in your formula sheet as well. Transforming a z-score to an x value. X is equal to mu plus z sigma. X is equal to mu plus z sigma. Oops, sigma. So that means my x value is going to be mu 7.3 plus z 1.645 times sigma, which is 1.4. Okay, so that means I've got 7.3 plus 1.645 times 1.4. 9.603. X is equal to 9.603. So 95% of men should be sleeping at least 9.603 hours. Luke.
Yep, that's me.
Luke wants to sleep for longer than 80% of the average male. He's like, I'm going to sleep. I'm going to get some good rest. He sleeps for 8.8 hours on average. Does Luke sleep? Does Luke have to sleep longer? How much more time does he need to sleep to satisfy his goal? All right, so 8.8 hours. Let's see. Actually, you know what? We should just do it with 80%. Let's find, if he wants to be more than 80%, let's find that 80%. Find that in the table. What's 80% come out to be? Yeah, let's just go with 0.84 because it's a lot closer to 0.84 than it is to 0.85, right? Let's say 0.84. Unless it's directly in the middle, just round it to the nearest one. Because again, you're rounding it to the nearest hundredth here, and for our purposes, that's probably pretty good. What do we say? 0.84?
Yeah.
0.84. That's your z-score. All right, so x value, transforming it from a z-score into an x value. X value is 7.3 plus mu plus z sigma 0.84 times my sigma of 1.4. All right, so 7.3 plus 0.84 times 1.4. Okay, so 8.4, 8.5. Oh, does he need to sleep longer? No, he does not need to sleep longer. He has already met his goal. How much time can he cut back on then? 0.3. Yeah, 0.3 of an hour if he wanted to. 0.3 of an hour. You could sleep 18 minutes less if you wanted to. Set that. You go to sleep 18 minutes later. All right, questions on any of the review? You feel good about all that?